Why do successive ionization energies increase in magnitude? We need to understand what ionization energy represents so that we can answer this question. The electron lost during ionization is so far away from the influence of the nucleus that it can no longer experience an attractive force from the nucleus. We can say that it is an infinite distance from the nucleus, and the energy of the electron has to be increased to a particular value for it to be moved. Just a second.
Yeah.
So the energy of an electron has to be increased to a particular value for it to be removed. And for any given atom, the energy value that the electron has when it reaches this position will always be the same, regardless of where an atom has come from. If an electron already has a high energy, then it will not need to gain much energy to be removed. But however, the electron in an orbital of a low energy quantum shell, for example, the 1s orbital, then will need more energy. Why? Because it's the closest to the nucleus. अगर आपने 2s से रिमूव करना है या 1s से रिमूव करना है, ऑब्वियसली 1s में आपको ज्यादा आयनाइजेशन एनर्जी लगेगी बिकॉज वो न्यूक्लियस के ज्यादा क्लोज है. 2s इज वेरी फार अवे फ्रॉम द nucleus and 3s would be even further away from the nucleus. So ionization energy is equal to energy of electron when removed and the minus the energy of electron when it was in the orbital, and it depends on the energy and how far it is from the nucleus, what energy level shell it is in actually. Why do successive ionization energies of sodium increase? Because the first electron is to be removed from which have the highest energy of any electron. क्योंकि सोडियम क्या होता है? 1s2 2s2 2p6 कितने हो गए? 9
10 now.
3s 1. So once you are
Right.
done
Yeah.
removing it over here, there would be a large jump. एकदम से जंप आएगा. लेट्स से अगर यहाँ पे आपको 100 लग रही है, यहाँ पे आपको शायद 2000 लगे. And then after
So
that,
energy.
ज़्यादा jump नहीं आएगी because there was a change of shell. You moved closer to the
Yes.
nucleus. Exactly.
Mm-hmm.
So there's a large jump from the first to second ionization energy because the second electron to be removed is in the quantum shell of a considerably lower energy. The second quantum
Right.
shell, there is a steady rise in ionization energy from the second to ninth electron. This indicates that the 8 electrons all exist within the same quantum shell. And as each successive electron is removed from the shell, the electron-electron repulsion within the shell decreases. फिर उसके बाद लास्ट जंप दोबारा कब आएगा? व्हेन यू आर गोइंग टू रिमूव द नाइन्थ इलेक्ट्रॉन, व्हेन यू आर डन विद 8 मोर. अब आपको दोबारा
Mm-hmm.
नाइन्थ रिमूव करने जाना है. नाइन्थ के लिए
Right.
अगेन देयर वुड बी अ लार्ज जंप बिकॉज नाउ यू आर मूविंग वेरी वेरी क्लोज टू द nucleus as well. Got it?
So a large energy would be used.
Exactly. So what determines the energy of an electron? एक एग्जांपल लिखते हैं हाइड्रोजन एंड हीलियम की. One of them is 1s1, the other is 1s2. Now the outer electrons of both atoms are in 1s orbital, and you must be thinking they would have the same energy. लेकिन 1s का orbital contains of helium में दो हैं. यहाँ पे दो इलेक्ट्रॉन है इसके 1s में और वहां पे 1 इलेक्ट्रॉन है. अब इधर क्या होगा? देयर वुड बी अ शील्डिंग इफेक्ट ओवर हियर. यहाँ पे शील्डिंग इफेक्ट क्यों होगा? बिकॉज ऑलरेडी प्रेजेंट इलेक्ट्रॉन इज गोइंग टू रिपेल द अदर इलेक्ट्रॉन टू लीव माई होम, whereas there is no conflict over here because यहाँ पे तो lone electron है. Whereas over here there were 2 electrons and there is a repulsion from a negative to a negative electron. We call this the shielding effect. Got it?
Right. Yeah.
Even though the nuclear charge of helium is double of that of hydrogen, this is because it contains 2 protons as opposed to hydrogen's 1 proton. And this effect is in the increased nuclear charge is to decrease the energy of the 1s electrons since they are attracted more strongly. अब यहाँ पे जब shielding increase हो जाएगी, आपको helium की जो this means that the first ionization energy of helium is going to be 2370 kilomole larger than hydrogen because increased nuclear charge भी आपके पास है, increased number of you have protons as well. And if we now
Yeah.
look at helium and lithium, यहाँ पे the nuclear charge of lithium is +3. It can lose up to 3 electrons. Helium तो दो ही lose कर सकता है. But however,
Yeah.
the
Basically.
outer electron of lithium is in the second quantum shell. इधर easy होगा. यहाँ पे there is going to be, यहाँ पे जो shell है वो high energetic है, so less ionization energy would be needed because it's far away from the nucleus as well. Got it?
Yeah.
Is it clear?
Yes, I think I got it.
So it also depends that greater the number of protons, greater the ionization energy. Further away the electron is from the nucleus, lesser the ionization energy, and greater the shielding effect, lesser the ionization energy. Got it?
Okay. Yeah.
So trends in ionization energy देखिए, across the period it always increases. Tell me why.
Okay, say the question again.
Across the period, ionization energy is always increase. Why?
Mm, because more energy is required to move down.
Why? Across a
Because
period,
the
why is it increasing from sodium
because
to magnesium to aluminum? Tell me quick.
more energy is required to move down the periods.
Period is across. How is it down?
No, no, sorry. The shells to move.
I don't get it. What are you saying? I know more energy is required as you move towards the right. Why is more energy required? Because proton number is increasing. The nuclear charge is increasing. Got it?
Okay,
Sodium has a +1 charge. Magnesium has a +2 charge. Aluminium has a +3 charge. No?
right. Yeah.
Right? तो ये वो हो जाएंगे. So as you move from, let's say, lithium to neon across period, the nuclear charge increases as the number of proton increases, which would lead to increased attraction between nucleus and electron. And when there's an increased attraction between the nucleus and an electron, the ionization energy needed to remove any electron would also increase. And
Mm-hmm.
therefore, the decrease in the energy of the outermost electron. Outermost electron is so far away that it is now very less energetic. Got it?
Mm-hmm.
Because higher, further the shells are away, they have a higher energetic. ठीक है, वो ज्यादा energetic होते जाते हैं ना. Is it clear?
Yeah.
Good.
Okay. I think I got it.
Why? What are you confused in?
No, no, I think I understand. I think you just need to repeat it one more times to get it in my head.
Yeah, you'll get it. It's not tough. ठीक है. Just remember all
Okay.
of the reasons. अब down the group अगर हम देखें, what will happen down the group? Down the group, you know that period number is changing. Shells are increasing. Across the period, shells remain the same. But यहाँ पे the atomic radii is increasing as you move down the group. So ionization energy would decrease down the group. Why? Because the electron is getting further away from the nucleus. Got it?
Yeah.
Good. यहाँ पे क्या है? यहाँ पे stronger हो रही थी because nuclear charge is increasing और आपके पास same number of shells हैं. Atomic radius
Mm-hmm.
is not increasing, it is constant. Increasing attraction because increasing nuclear charge and proton numbers are increasing, hence ionization energy was increasing. यहाँ पे decrease क्यों होगी? Because it is getting far away from the nucleus, it's easy to remove. Plus shielding effect भी तो बड़ा हो रहा है. अगर आप
Yeah,
यहाँ पे देखो,
it
this
requires less
electron,
energy to remove from the
yes,
atom.
it's now easy to remove. क्योंकि look at this electron is going to face repulsion from so many more, right?
Yeah.
But this electron is going to face repulsion from only these two electrons. And this electron won't even have to face any. We call this the shielding effect. This one is the one
Yeah.
which is facing the most shielding effect, largest shielding effect. And it also has the largest distance from the nucleus, hence lowest ionization energy. Got it?
Yep.
Good. So first ionization energy, second ionization energy, third ionization energy key values you have to, and definition is very important to remember all of these. Now let's
Okay.
start off with periodic table. Can you tell me what do the periods and the groups tell us about the elements in periodic table?
Uh, the groups talks about how many protons is no electrons in the shell and protons. No,
Wrong.
the
Think
valence
again.
electrons. The group shows the valence electrons, so the electrons in the last shell, how many there are. Uh, and periods is how many uh no, not shells, but
You're right,
not
it's
layers.
shells. What are you confused
Shell,
with?
yeah, layers.
It's simple IGCSE question. Okay.
Mm-hmm.
Groups are the vertical columns in the periodic table and all elements in the main group. Groups कौन कौन से 1 to 8? जैसे ग्रुप 1 है alkali metals, ग्रुप 7 halogens है, ग्रुप 8 noble gases है, ठीक है. And these are the electronic configurations का ही पता होना चाहिए कि how are the electronic
Yeah.
configuration written. ग्रुप 5 वाला क्या होगा? NH2 NP3. The next one would be NS2NP4. वो कुछ भी हो सकता है, 1s2, 2s2, 2p4 या 3s2, 3p4। ठीक है, जो अगला वाला होगा वो 4s2, 4p4 होगा। All elements in group 7 would be how? 2s2, 2p5, 3s2, 3p5, right?
Yeah.
Periods are the horizontal rows, and all elements in a period have the same number of quantum shells containing electrons. For example, Li to Ne have the electrons in both first and second quantum shells. They all have two shells. Blocks in the periodic tell us that where in which subshell is the outermost electron in. Group 3, 4, 5, 6, 7, 8 के जो भी electronic configuration होगी, it would always end up with 2p, 3p, 4p or 5p. D block element would always end at 3D or 4D. S block elements would always end at 1s, 2s, 3s, 4s. That is how we name these blocks in which they are present. The P block consists of the elements in group 3 to 4 inclusive. A P block element has its highest energy electron in a p orbital, and the D block consists of the elements scandium to zinc. In period 4 and yttrium, तो ये सारे क्या हो रहे हैं, वो gradually increase कर रहे हैं. So now you know what is the meaning of S block, D block, and P block. Clear?
Yep.
Groups are the vertical columns in the periodic table, and periods are the horizontal rows in the periodic table. Groups tell us the valence electron, the number of electron in the outermost shell, and the periods tell us the number of shells. Periodic properties. What are periodic properties? The elements in period exhibit periodic properties, also known as periodicity. We can illustrate the idea of the periodic properties by looking at the elements in period 2 and 3. And we have already seen one example of periodic properties, a regular repeating pattern of electronic configuration. अब हम बाकी trends की बात करेंगे, such as number 1, atomic radii. The atomic radius of an element is a measure of the size of its atom. It is the distance from the center of the nucleus of atom 1 to the center of the nucleus to atom 2. So ये क्या है? It is the atomic radius. Now, if you look across the period, the atomic radius decreases or increases?
It increases.
What?
It would increase
Why?
because there are more like layers.
Why are there more
More
layers? Is
shells.
it the same period? Period number 2 की बात हो रही है ना. So all atoms in
Yeah.
period 2 would have the same number of shells, 2 shells. The radius would decrease.
But wouldn't it just stay the same?
It won't. क्यों? Because I told you, as the number of electrons increase, the shells remain too, but they move closer to the nucleus. Why? Because there is increased attraction between the nucleus and the outermost electrons. Got it?
Okay. Yeah.
जो nucleus और outermost electrons के दरमियान attraction होगी, force of attraction, that is actually increasing. Shells remain the same. Why would it increase? That was a wrong answer. Huh? And what about down the group?
It would increase.
Why? Because shell number is
There.
period
Yes.
number is increasing. Good. So the radius we are measuring is called the van der Waals radius. क्योंकि इनके दरमियान जो forces होती हैं, we call them the van der Waals forces as well. So here you can see, as the atomic number increases across a period, आपके पास जो atomic radius है वो क्या हो रहा है? Decrease. Because when electrons increase, there is a greater attraction. The shells remain the same. Okay? The shells remain the same, but they are getting closer to the nucleus. So radius ka size, shells remain the same, shells just come closer to each other. You can see that the radius decreases across each period, and this is because as the number of protons in the nucleus increases, so does the nuclear charge. This results in an increase in the attractive force between the nucleus and the outer electrons, and increase in electron repulsion as the number of electrons in the outer quantum shell also increase. Second property जो हम discuss करेंगे, that is the melting and boiling temperatures. अगर हम across the period देखें, what happens to the melting temperature? It is actually increasing. Melting temperature increase कर रहे हैं. Boiling temperatures are also going to increase क्योंकि metallic compound है, metallic है, and then you are also moving towards joint covalent structures तक भी आ रहे हैं. And then after one point, आफ्टर ग्रुप नंबर 4, ग्रुप 5, 6 और 7 में जब दाखिल होते हैं दे डिक्रीज। सबसे ज्यादा जो मेल्टिंग एंड बॉइलिंग पॉइंट्स होंगे वो किसके होंगे? ग्रुप 1,
Uh,
2 एंड 3, बिकॉज दे आर मेटल्स। ग्रुप 4 आर द जाइंट कोवेलेंट स्ट्रक्चर्स। और ग्रुप 5, 6 और 7 पे डिक्रीज हो जाएंगे बिकॉज दे आर नॉन मेटल्स। गॉट इट?
you're right.
So first they increase and after group 5 they decrease
Decrease.
because the type of bonding is first metallic, फिर covalent and it remains covalent when we talk about non-metals. स्ट्रक्चर की बात करें, मेटल्स हैव अ जाइंट लैटिस स्ट्रक्चर इंक्लूडिंग ग्रुप नंबर 4, लेकिन जो ग्रुप 5, 6, 7 है नॉन मेटल्स, दे हैव अ सिंपल मॉलिक्यूलर कोवेलेंट स्ट्रक्चर। पीरियड 3 में भी अगर आप देखें, फर्स्ट मेल्टिंग एंड बॉइलिंग पॉइंट्स आर इंक्रीजिंग अप टू सिलिकॉन, क्योंकि सोडियम इज अ मेटल, magnesium is a metal, aluminium is a metal. Silicon has the highest melting and boiling point because it's a macromolecular giant covalent structure. Silica, silicon dioxide, वो बिल्कुल डायमंड की तरह होता है, रिमेंबर?
Right. Yeah. Yeah.
ठीक है। एंड देन द मेल्टिंग एंड बॉइलिंग पॉइंट डिक्रीज फ्रॉम फास्फोरस, सल्फर, क्लोरीन बिकॉज दे आर नॉन मेटल्स। यहाँ लिखा हुआ है ना, फर्स्ट थ्री
Mm-hmm.
आर मेटेलिक, सिलिकॉन इज
Metallic.
जाइंट
Second, they are
कोवेलेंट,
covalent
and phosphorus,
and
sulfur,
it's
chlorine
simple.
are simple covalent. Giant lattice is simple. These are so easy to remember. This chapter isn't even difficult. You just have to revise one more time and trust me, it's not tough. Got it?
Yeah.
So you don't think that the speed is too fast. It's not tough. You can do it. You have many days. You have a lot of time in a day to read the book. You have the book. I'll send you the notes. You have my PowerPoints as well. There's so much stuff that you can read, you can practice. And you know, I am leaving all the questions right now, whatever come. You can solve all these
Yeah.
checkpoints on your own. I haven't solved one because I know you can solve all of them. It's such an easy chapter. The third property we'll discuss is the first ionization energies. You can see that hydrogen to helium first ionization energy increase कर रही है, then there's a sudden decrease. क्यों? नेक्स्ट पीरियड पे मूव करेंगे, पीरियड 2 पे। अब ये पीरियड 2 की है, then again decrease. क्यों? now it's period number 3. got it?
Yeah.
तो ये जो लास्ट जंप आया है, दिस इज अ जंप फ्रॉम पीरियड 1 टू पीरियड 2, दिस इज अ जंप फ्रॉम पीरियड 2 टू पीरियड 3 एंड इट गोज ऑन टू आर्गॉन। आगे दोबारा जंप आएगा अगर आप पीरियड 4 पे जाओगे, क्योंकि पीरियड 4 पे डिक्रीज क्यों आएगा? पीरियड नंबर चेंज हो गया, एटॉमिक रेडियस बढ़ गया, आयोनाइजेशन एनर्जी डिक्रीज कर जाएगी। क्लियर?
Yeah.
अब यहाँ पे यू कैन सी, you must be thinking that it should keep on increasing. Why is there a dip? What's the reason for this dip? Look at this. The reason for this dip is that there's a lower ionization energy needed to remove this electron because p shell is high energetic. High energetic p subshell lower in ionization energy लगती है. So that is why there's a dip from beryllium to boron and then again an increase. लेकिन आप देखोगे थोड़ी देर बाद दोबारा एक dip आ गया between nitrogen and oxygen. What's the reason for the dip over here? Can you look at the
Uh,
electronic configurations and tell me?
uh, and they have in second 2p2 it has one more proton.
तो यहाँ पे क्या होगा? रिपल्शन, देयर वुड बी अ फाइटिंग।
Yeah.
उस फाइट को हम क्या कहते हैं? स्पिन पेयर रिपल्शन। एंड दिस सेकंड वन वुड लाइक टू रिमूव वन, क्योंकि ऑल ऑफ देम आर सिंगल इन नाइट्रोजन, सिंगल सिंगल सिंगल।
They will want to be single.
बट यहाँ पे 2p वाले जो है ना, दे आर बोथ गोइंग टू स्टार्ट फाइटिंग एंड द फाइट इज गोइंग टू हेल्प यू टू रिमूव द इलेक्ट्रॉन वेरी इजीली। तो ऑक्सीजन की लोअर आयनाइजेशन एनर्जी होगी देन
Yeah.
नाइट्रोजन। गॉट इट?
Yeah.
And that is the end of your unit 1 topic number 2. Now I'll show you a video regarding ionization energy as well, and then you're going to solve the whole exercise of topic number 2 as well. Got it?
Yeah.
Topic number 2 पूरा complete हो गया. It only consisted of 2A, ठीक है, and 2B. 2B हमारा periodic table था और 2A आपका atomic structure था.